In the last video, you reviewed information about valence electrons. In this video, you will learn how these valence electrons are exchanged in order for ionic bonds to form. What is an ionic bond? Ionic bonds result from the electrostatic attractions between cations, which are positively charged ions, and anions, which are negatively charged ions. In these bonds, electrons are transferred between elements. What elements are going to be cations? Cations are positively charged ions, so these will typically be metals, which have a low ionization energy and are willing to give up a valence electron more readily. What elements are going to be anions? Anions are negatively charged ions, so these will typically be nonmetals, which have a high electronegativity and so readily attract more electrons to their valence shell. Ionic bonds can occur between a metal and a nonmetal, such as sodium and chlorine, a metal and a negatively charged polyatomic ion, such as potassium and nitrate, or NO3, a positively charged polyatomic ion and a nonmetal, such as ammonium, or NH4, and fluorine, or two polyatomic ions, such as ammonium, which is NH4, and sulfate, which is SO4. Polyatomic ions are simply ions composed of more than one atom. A list of polyatomic ions can be found on the back of your periodic chart. This list will be very important in the next unit. The properties of ionic compounds are that they are not discrete molecules. The lowest ratio of elements is called a formula unit. The elements bond together to form a solid crystal structure. Note the pictures in the upper corners of your screen. They are often referred to as salts. The strong bonds cause high melting and boiling points. Most are soluble at least to some extent in water, and they conduct electricity in molten or dissolved forms. Examples of ionic compounds include sodium chloride, which is found in table salt, sodium hypochlorite, which is found in bleach, magnesium sulfate, which is found in Epsom salts, which are used to reduce swelling and as a laxative, calcium carbonate and magnesium hydroxide, which are used to relieve heartburn. Calcium carbonate is also in chalk and limestone. Calcium chloride is a salt used in pickling. Sodium fluoride is the fluoride found in toothpaste. When drawing the Lewis dot structures of ionic compounds, you must keep several things in mind. The overall charge in a compound must equal 0. If it does not equal 0, it is not a compound, it is an ion. Cations wind up with a positive charge and no dots, which represent the valence electrons inside the brackets. Anions wind up with a negative charge and 8 dots inside the brackets. The first step in drawing the Lewis dot structures is to determine which elements are present in the compound and write their symbols. Sodium is Na and chlorine is Cl. Next, determine the number of valence electrons and place the correct number of dots around the symbol. Sodium is in group 1, so it has 1 valence electron. Chlorine is in group 17, so it has 7 valence electrons. The metal atom will donate valence electrons to the nonmetal atom so that the nonmetal atoms can complete their octet. By doing this, both atoms will look like the nearest noble gas, which has a more stable electron configuration. Sodium is the metal. It has a low ionization energy, so its valence electron can be easily removed. Chlorine is the nonmetal. It has a high electronegativity, so it will pull the electron from sodium to itself and keep it there in its valence shell. The sodium atom has no more valence electrons to donate, and the chlorine now has a full octet. Place brackets around each atom and assign the correct charge to each atom. Sodium lost 1 electron, so it has a +1 charge. Chlorine gained 1 electron, so it has a -1 charge, and is now called a chloride ion. Notice that the charges add up to 0 because a +1 and a -1 add up to 0. In this example, you have magnesium and oxygen forming a compound. Magnesium is Mg and oxygen is O. Magnesium is in group 2, so it has 2 valence electrons. Oxygen is in group 16, so it has 6 valence electrons. Magnesium is the metal, so it will donate electrons to oxygen. Notice that oxygen needs 2 electrons to complete its octet. Conveniently, magnesium has 2 to donate, and it will donate both of them to the oxygen. The magnesium atom has no more valence electrons to donate, and the oxygen atom has a full octet. Place brackets around each atom and assign the correct charge to each atom. Magnesium lost 2 electrons, so it has a +2 charge. Oxygen gained 2 electrons, so it has a -2 charge and is now called an oxide ion. Notice that the charges add up to 0 because a +2 and a -2 add up to 0. In this example, you have magnesium and chlorine forming a compound. Magnesium is Mg and chlorine is Cl. Magnesium is in group 2, so it has 2 valence electrons. Chlorine is in group 17, so it has 7 valence electrons. Magnesium is the metal, so it will donate electrons to chlorine. Notice that chlorine only needs 1 electron to complete its octet, but magnesium has 2 to donate. It must donate both its valence electrons. So you must draw another chlorine so that the second electron can be taken from the magnesium. The magnesium has no more valence electrons to donate, and the chlorine atoms have a full octet. Place brackets around each atom and assign the correct charge to each atom. Magnesium lost 2 electrons, so it has a +2 charge. Each chlorine gained 1 electron, so each chlorine has a -1 charge, and they are now called chloride ions. Notice that the charges add up to 0 because a +2 plus -1 plus -1 add up to 0. Pause the video and try to draw the correct Lewis structures for each of the compounds. The subscript behind the atomic symbol indicates how many of that type of atom are in the compound. For example, for CaCl2, you must draw 1 calcium atom and 2 chloride atoms. Restart the video when you are ready to see the answers. In the next video, you will learn about the bonds in metals and metal alloys. Thanks for watching.